All right, so before we write the quiz, we're going to do this lesson. This stuff is not on the quiz, but this way you can have the rest of the class to do the quiz instead of starting it now and then me putting a time limit on it. So you'll have more time to do the quiz this way. So we're looking at inequalities. So far we've been looking at creating and solving linear equations that have only one solution. There can only be one value of x that satisfies the equation. You don't have this? It should have everything in it. Yeah, it's in here. Page 11. Where's your booklet, Beckham? Run fast. Oh, yes. Lesson 5 in chapter 4. So page 11, right? Okay. So with the equations, there's only one solution, only one value of x that satisfies the equation. So now we'll look at linear inequalities where there may be an infinite number of values for x that will satisfy the inequality. So an inequality is a statement that relates two quantities or expressions using these symbols, either less than or greater than, less than or equal to, or greater than or equal to. So when you have that line underneath there, Kiana, that means also equal to. You have your phone out? Okay. Tell her hi from me and that you can't talk anymore because you got to learn math. Okay. So for example, 2x plus 3 must be greater than or equal to 7. Or 5x must be less than 20. Or 13 is greater than 12. So we'll learn how to graph inequalities on a number line, and then we'll get into actually solving inequalities. So remember that this symbol represents greater than. Now, the way to remember this is that it always opens towards the bigger value or points towards the smaller value. So we're going to have some inequalities that involve greater than. If there's a line underneath it, it means greater than or equal to. If it's pointed, so the smaller thing is pointed to the left, that means less than. A line underneath it is less than or equal to. Okay? And on a number line, we're going to use arrows with either an open or a closed dot. And that dot will be at your starting value. And it's either going to be open or closed. So if it's closed, that means that the starting value is also included. That's why this stands for less than or equal to. It's going to the left, which means all values less than a value. And because the dot is closed in or circled in, colored in, that means also equal to that value. But if the dot is open, that means that the beginning value is not included. So that represents just less than. This next one, because it's going to the right, it's greater than, and because the circle is colored in, greater than or equal to. The last one, it's going to the right, which again is greater than, and because the circle is not colored in, it is not equal to the beginning value. So again, we use an open dot if the number is not included in the solution set, and a closed dot if the number is included. So just some practice graphing inequalities, and then again we'll get into actually solving them. So we want to graph this inequality. If we're told that x must be greater than negative 3, but also it's a real number, so that's important as well. Okay? It has to be a real number, which means all fractions, all decimals are included. We're going to see some examples where the variable is not real numbers, but integers. And integers are only positive and negative counting numbers, not fractions and decimals in between. So we'll see how we handle that. But in this case here, it says that x must be greater than negative 3. So because of that, you're going to have an open dot on negative 3, Open dot because x is only greater than, not equal to. There's no line under the greater than symbol. And because it's greater than, that means we have to have an arrow going off to the right. Because as you go to the right on a number line, your values get larger. So that's the graph of that inequality. That shows all values of x that are greater than -3, not equal to, which is why we have an open circle there. And x is a real number, which we show by using a solid line. So that shows all fractions, all decimals are included. Part B says x is less than or equal to +2. So you're going to have a dot at +2, and in this case, it's going to be colored in, because not only is x less than 2, but it's also equal to 2. This line underneath the less than sign means also equal. And again, because it's less than, we're going to have a line going off to the left now with an arrow on the end. And a line is used because we're talking about x belonging to the set of real numbers. And that line shows that all fractions and decimals less than or equal to 2 are part of this solution. So those first two examples had a starting point but no definite ending point. This next example, you're going to have a starting and an ending point. This one says that x must be greater than -2. So we're going to start at -2, and that dot will be open because x is only greater than -2, not equal to, but it's also less than or equal to +4, which means we're going to have a closed dot on +4 because 4 is included. And because x is an element of real numbers, we will have a solid line in between those two dots. So something that you might do, let's say that you're having trouble seeing your lines on the number line, because maybe you're using pencil and it's not dark enough, you can draw your line slightly above the number line, just so it's clear that that line is there. So you can draw it above the number line if you want, just to show that it's clear that it's there. Now, this next one's different because it says x is a whole number. All right? So you got to know what whole numbers are. Whole numbers are only counting numbers, no fractions or decimals, and they include 0. This says that x must be greater than -1. So if you want, you could put an open dot on -1. And because x belongs to the set of whole numbers, the first whole number greater than -1 is 0. So we'll put a closed dot on 0, and we cannot use a line here because a line is only used when you have real numbers. When you use a line, you're saying all decimals, in this case greater than -1, are part of the solution, or all decimals greater than 0 are part of the solution, and that's not true. We can only use dots here because whole numbers are only positive counting numbers, including 0. And then I'll put an arrow going off to the right to show that that pattern is continuing. And that arrow must be there because without it, whatever your last dot is, you're saying that that's where it stops. But this doesn't. That pattern continues. So part E says x is less than or equal to 1, where x is an integer. So again, integers are only positive and negative counting numbers, no decimals or fractions. So we're going to start at +1, which is included because x is less than or equal to. And the next integer less than 1 will be 0, then -1, then -2. And note that those dots need to be colored in because those values are part of the solution set. And we need an arrow there to show that that pattern continues. So for these next examples, we're going to do the opposite. We are given the graph, we want to write the inequality. So this first one starts at -10, and the -10 is colored in, which means it's included. and the line goes to the left, which means all values that are less than or equal to -10. Now you can use any variable you want. The most common one is x, but it can be any letter. So we would say that x is less than or equal to -10. As well, we would say that x is an element of the real numbers. So that funny e, a rounded e, that stands for is an element of in math. And we use r to represent real numbers. And the reason we're using real numbers is because a line is used from -10 going to the left. Remember, when a line is used, that means all fractions, all decimals, all real numbers less than or equal to -10 are part of this relation. Question B. You've got an open dot on -4/7. And the line goes to the right, which means the values are getting larger. And because it's a line, that means, once again, real numbers. Because you have an open dot on -4/7, that value is not included. Now I said, you can use any variable you want, any letter. I've chosen to use y in this case. So I would say y is greater than -4/7. And again, because a line is used, that means that we're using real numbers. Y is an element of the set of real numbers. Question C uses real numbers again because you've got a line, but this one has a starting point and an ending point. So if you want, you could write this in two different statements if you wanted to. You could say, let's say we use the variable p is greater than or equal to 4, comma, p is also less than 8. And again, p is an element of real numbers. Real numbers because a line is used between 4 and 8. Now, I said there's a couple different ways you could do this one. You could write it instead of two statements. You could write it as one statement. Okay? So it would look something like this. So you go from smaller number usually to larger number. We would say that p is greater than or equal to 4 and also less than 8. So instead of two different statements, you can write it as one statement. Both are fine. It doesn't matter. You may find it easier to write two separate statements, and that's perfectly fine. Now, for question D, I would probably use two different statements here because it's not a continuous set of solutions like the previous one. In this case here, you've got one line going to the left from 3, and 3 is not included. So we might say that m is less than 3, comma, and then you got another set of solutions starting at +6, which is included, and the graph goes off to the right. So m is greater than or equal to +6. And once again, because lines are used, we would say that m is an element of real numbers. So that's how I would probably do that one. It is possible to use one statement, but the inequality symbols will be going in different directions. If you look at part B above, the second way we did it with one statement, the inequality symbols are both pointing the same direction. If you were to write D with one statement, the inequalities would be in different directions, which is fine. It's not wrong. So what's different about E is that you've got dots there. So now we're talking about integers. And you can see it goes from 4 down to 3, down to 2, down to 1, down to 0, and look where the arrow is. It continues to the left forever. So in this case here, again, we can use any letter we want. Maybe we'll use the variable b must be less than or equal to +4, And now B belongs to the set of integers. B belongs to the set of integers. There's no line, which means none of the fractions or decimals between 3 and 4 or between 2 and 3 are part of this solution. Only the integers. Okay. Part F, very similar, except now we're dealing with real numbers, and we're going to have two different statements here. So I might say if my variable is t is less than or equal to -3/7, comma, t is greater than or equal to 1/7. Notice that both dots are colored in, so those beginning values are included. And because lines are used, we would say t is an element of real numbers. For most of them that we do, it's either going to be real numbers or integers. If there's dots, you can use integers. In some cases, you could use whole or natural numbers, but you can always use integers if you have dots. But you can't always use whole or natural because whole numbers are 0, 1, 2, 3. Positive counting numbers including 0. Natural numbers do not include 0, but only positive counting numbers. So you have to be careful using those two number systems. So I think it's easier if we have dots just to use integers. Do question G on your own, and then we'll check it. So this line, which means you're using real numbers, starts at 1, which is not included. You can use any variable you want. Keen, which one did you use? Which variable did you use? Because I asked you, that's why. Oh, you're using the letter Y. Okay. And what's the rest of it look like? Don't say Y again, because then I will get mad. Comma. You agree with that, Kira? Yes. That's correct. What about H, Lena? Don't ask me why either. I'll get mad. Don't be like Keen. Always causing trouble. And what do you think, Beckham? Is she right? Yes, absolutely. So in this case here, the original number line was in a red color. Actually, no, I'm sorry. The original number line was black. And so you've got an open dot on 0 and an open dot on 8 with a line in between. So if you want to write two different statements, that's fine. You would say that, let's say P is greater than 0, comma, P is less than 8, comma, P is an element of real numbers. Or if you want to write it as one statement, again, always start with the smaller number first. with the variable in the middle. So P is greater than 0 and less than 8. And P belongs to the set of real numbers. Did you sign in? Okay, so either of those is fine. Either of those. What about question J, Liam? No? Can you help him, Riley? You're just being shy because I know you know this. Jace. Okay, well, you got a series of dots, which means it's integers. And look where the arrow is. It's on the left side pointing to the left. So that means the integers are getting smaller. So we're starting at -1, which is included. So maybe we'll use a variable t less than or equal to -1. And now, because again it's dots, t belongs to the set of integers. So that's that inequality. Question K has a starting point and an ending point. It starts at -1, which is included. It goes up to 3, which is not included. So you could write it as two statements if you wanted. T is greater than or equal to -1, comma. T is less than 3, comma. T is an element of real numbers because a line is used. Or if you wanted to use one statement, again, always start with the smaller number. T is greater than or equal to -1, but only less than 3. And again, T is an element of real numbers. So either one of those is fine. What about the last one, Hannah? Yeah, you do. So you see dots, so what does that tell you? When you see dots, what number system are we using? Integers, yep. And this one's going to have two parts for it. If we just look at the part on the left, where is it starting? And which direction is it going? Left. So you would say that T is, and you can use any variable you want, just don't be like Cain and use Y. Let's use A. A is less than or equal to -9. What will the next part look like, Brooklyn? Where does it start on the right? Pardon? At 8. And you see the arrow going to the right tells us that that pattern continues. So A is what? Greater than or equal to, because this first dot is closed in, +8. And now we will say that A is an element of I for integers because it's dots. Okay? So example 3 says at a spring fishing derby, only fish 34 centimeters or longer qualify for prize categories. Express the above statement algebraically, define the variable that we use. So because we're talking about the size of the fish, that's what our variable will have to represent. And we could say S for size or L for length. Doesn't matter. And so in order to qualify for a prize, it must be 37 centimeters or longer. So we could say L is greater than or equal to 34. There's our inequality. And to put it on the number line, let's put 34 right in the middle. And really, that's all the numbers that you need. If you want, you could definitely put other numbers there. I'm going to skip the 35 just so everything's not so squished together, but that represents 35. The next one is 36, 37, 38. As you go to the left, you get smaller. So if we go down, that'll be 33, 32, 31, 30. And in this case, L must be greater than or equal to 34. So we put a closed dot on 34. And we're going to have a line going off to the right because it's possible for a fish to be 34.5 centimeters or 34.9 centimeters. All fractions, all decimal, greater than or equal to 34 are possible. So there's that inequality. So example 4 says, in 5 years, Samantha will be earning more than $25 per hour at her current job. Write an inequality to represent Samantha's current rate of pay. So in 5 years, Samantha will be earning more than $25 per hour at her current job. Write an inequality to represent her current rate of pay right now. So that means it has to be, right now, her pay has to be less than or equal to 25. Because in 5 years, she's going to be earning more than that. It might be $25.01 an hour, but it'll be greater than 25. So right now, her current pay is less than $25 per hour. So if we say that we're going to let P equal Samantha's current pay, and because we said it's going to be less than 25, so when we draw our number line or put a number line, we'll put 25 in the middle. As we go to the right, we'll get larger. So the next one will be 26, then 27, 28, then 29. As we go to the left, we get smaller, 24, 23, 22, 21. And so our dot in this case will be open on the 25 because it's less than 25, not equal to. And again, we'll have a line going off to the left. It can be any dollar value less than 25. It could be $24.99. That's possible. Example 5 says the perimeter of a square is less than 40 centimeters. Write an inequality in terms of its sides to represent this problem and graph the solution. Okay, so P, the perimeter. Let's let P equal the perimeter here. And it must be less than 40 centimeters. Now, it says it's a square, which means all the sides are the same. Okay? So it does say write the inequality in terms of its sides, so I'm going to have to fix this. Let's say that we're going to let S equal the length of each side, because we need to write the inequality in terms of its sides. So if it's a square, all four sides are the same length. Right? If it's a square, all four sides are the same length. So we said that S represents the length of each side. So S, 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 S. The perimeter is the distance all the way around, so you're adding up all four S's. So 4S has to be less than 40. And if we want to get S by itself, we haven't done any work where we're solving inequalities yet. That will come tomorrow. But it's going to be the same process. You need to get S by itself. Hooked onto the S is a 4 by multiplication. So we do the opposite, which is divide both sides by 4. They cancel on the left, and you'll have S is less than 10. Each side must be less than 10 centimeters. So for our number line, we're going to have 10 in the middle. As we go to the right, we get larger. As we go to the left, we get smaller. And S is less than 10, which means we'd have an open dot on 10 and a line going off to the left. So that's what that looks like. Okay? All right. So that's it for today. I will hand out the quiz first. So you're going to work on that, get that done, and hand it in onto the filing cabinet. And then you can work on the assignment. There's a bunch of you that still haven't handed in that multi-step equations assignment, as well as 4.2. So those got to get done and handed in because they count for marks. Okay?